What is slope parameter B1? Well, during our high school days, our teachers taught us the basics of algebra. This is where we learned about point-slope form, which is a very important equation we used in order to solve many problems, and it eventually led us to other forms, such as the slope-intercept form. Well, you may have guessed it from the title, but slope parameter B1 is indeed a slope, and it is the slope of a regression line between two variables, which is the actual definition. The equation for a linear regression is y is equal to b1x plus b0 plus e. Does this seem familiar? Well, of course it does, because it is a slope-intercept form where b0 is the y-intercept and e is the error. There are many things that actually use linear regression with slope parameter b1, such as stock prices, when people are trying to determine what type of trend the stocks are moving in and whether to buy them or sell them. They are also used for gas prices to see if gas stations should wait to buy gas or stock up on gas depending on the slope. Even weather trends can be estimated with slope parameter B1. We can estimate how hot or cold the temperatures will get. There is an even more important thing we can do with this parameter. It might be even one of the most important things we can do. The scientific method is one of humanity's greatest achievements, and the ability to create hypotheses and test them is what keeps us moving forward as a species. Yes, if you guess where I'm going with this, we can actually use slope parameter B1 to create hypotheses and test them. What actually is hypothesis testing, though? Hypothesis testing is where we form a null hypothesis and an alternative hypothesis. We can then test these hypotheses using statistical tests and data to see if there is a significant linear relationship or not. There are a few important requirements we must be sure of before using hypothesis testing. The data must be linear, normal, independent, randomly taken, and they all must have equal variances. For hypothesis testing, we must first form our HO and HA values. Next, we must test them at certain confidence levels using slope parameter B1 and t-value and standard error. In order to test the data for significant linear relationships, we must use the formula B plus or minus t value multiplied by the standard error. Here's an example of how we can observe the slope parameter B1 from the graph. We can see the r-squared value isn't that close to 1, which means that the model can be improved upon. This is another example of hypothesis testing and how we can use the given data to calculate the confidence interval. We can also calculate the p-value in order to test our hypothesis to see if its value is greater than the significance value. If it is less than that, it means that it is not significantly linear. There are also more things we can do with slope parameter B1, as I'm only scratching the surface of its many uses, and I hope you will look further into this useful topic.